हाँ अथर्वा, हाउ आर यू?
Sir, I am good, sir.
वेयर आर यू फ्रॉम?
Sir, Nagpur.
नागपुर। अच्छा नंदन, गुड गुड आफ्टरनून। सो हाउ आर योर अदर क्लासेस गोइंग ऑन?
Good, sir.
सो एनी एक्टिविटी यू पीपल आर डूइंग? गुड आफ्टरनून नंदन। सो इसके बाद भी आपका क्लास है क्या? हाँ,
सही है सर।
नहीं है ना? अच्छा अच्छा अच्छा, ओके। नहीं, आज का प्रैक्टिकल थोड़ा छोटा और जल्दी मुझे खत्म करना है, बिकॉज आई हैव गॉट द मीटिंग इन द कॉलेज, so that is why I asked. तो बोर हो गए क्या आप लोग घर में? हेलो? बट अभी कुछ भी नहीं कर सकते उसके लिए, अभी क्या हो सकता है? जो नागपुर में जो लोग हैं दे कैन एटलीस्ट विजिट द कॉलेज, एक दो बार तो भी आ सकते हैं। बट आई डोंट थिंक दैट दे विल अलाउ यू टू एंटर द कैंपस। आए थे क्या कोई लोग कॉलेज में आए थे कभी? किसी ने विजिट किया क्या? आपने शायद, आपके बैच ने सिर्फ फर्स्ट ईयर में कॉलेज देखा ना, सेकंड ईयर तो आपका वैसे ही हुआ ना? अथर्व, एम आई करेक्ट?
यस
आपने
सर।
फर्स्ट ईयर विजिट किया ना कॉलेज?
यस सर।
बिकॉज यू आर BT19 ना। तो चलो एटलीस्ट एक साल तो, लेकिन जो बच्चे अभी सेकंड ईयर को है वो तो मैड हो गए हैं अभी। बिकॉज आई टीच टू सेकंड ईयर एज वेल ना, उनको मैं फ्लूइड मैकेनिक्स पढ़ाता हूँ। सो दे हैव नॉट सीन द कॉलेज फ्रॉम लास्ट 1 ईयर, 1.5 ईयर। अभी वो तो 2 साल तो उनके कैंपस के बाहर ही गुजरे। तो 50% इंजीनियरिंग का तो वैसे ही निकला उनका बाहर के बाहर। They have not feel the real heat of the department. Am I correct? आपको भी तो नहीं मिला है, आपका भी तो सेकंड ईयर ऐसे ही गया है। सुनाओ, चलो काफी लोग आ गए हैं, तो अभी स्टार्ट करें क्या सर? प्रैक्टिकल स्टार्ट करें, आज का छोटा सा ही है प्रैक्टिकल। चलो ठीक है, सो आई शेयर द स्क्रीन विथ यू। यार ये वेबएक्स ने परेशान करके रख दिया है। एक मिनट। So last practical we have seen the effect of transmission efficiency related to the will RPM. Okay, there we have seen that if you have found out that what is that delta NE, which I asked you to calculate here, ये जो delta NE, then you might have seen that this delta NE is for 95% is more compared to 97%. That means that much amount of additional RPM we have to run the vehicle for the getting the speed of what we desire. Okay. So now today's practical is based upon complete machine design. So have you studied the machine design by any chance? Have you studied the shaft design? The experiment number 5. Huh?
Yes, sir, we have studied.
Yeah, very good. Because that knowledge is going to be required here for designing of the shaft. So here we are going to design today the so it is AE lab 5. Okay. So experiment number 5. So aim of the experiment is to design the input to design the gearbox input shaft. Okay, so we have to design, let us say that if so if you see the theory, we know that we are going to have the engine here. So this is the engine. Now here this is the clutch housing and this is connected to the gearbox. From gearbox this can go to propeller, then propeller to differential and differential to wheel. So this is basically the gearbox input shaft. We have to determine the size of this gearbox. This is called as the clutch housing. Okay, this is differential, this is propeller shaft. See, for this we will require the engine characteristics. Okay, what is the engine characteristics? So for designing the gearbox input shaft, plot engine characteristics. So these engine characteristics are given, or you have already studied this, where you have said that this is your engine RPM and let us say this is the power. So if you see the power curve, so it is going to be like this. Okay, and this is the power curve. This portion is relatively flat. Rather I will just ये जो है सर, ये थोड़ा सा इसको सर थोड़ा सा यहाँ कट कर देते हैं, ठीक है. सो दिस इज योर, ये जो है ये आपका ये है रेटेड आरपीएम. ओके, तो ये है आइडल आरपीएम. Now if you see the torque curve, then it is almost like this, that the torque curve will get at this peak value and then it will move down. So ये है, ये गायब हो गया. एक मिनट सर, मैं टॉर्क कर फिर से ड्रॉ करता हूँ। ये ओके, आई विल यूज दिस कलर। तो सर टॉर्क कर, इफ यू सी it will be, this is going to be the torque curve, where this point, if you say torque, this is the T max point. Okay, so now if you know the rated power, so power is equals to 2 pi n t. So from here you can find out, so rated power is known, then you can find out the torque. So let us say that this torque is T1. Okay, so this is one way of finding the torque. The other way of finding the torque is the maximum torque is specified in engine specs. मान लो आप let us say if you are considering the design of I-20, then you the maximum torque and maximum power at which RPM is specified. So one torque you get from the maximum or you can say rated power. The other one is max torque. So this is from engine specification. Let us say this is 2. Then take maximum of T1 and T2. So whichever is maximum, you can take that, and then to this particular torque, the design torque TD, you can do it as 25% more, 2.5 into T max, either T1 or T2. So ये मैं आपको नहीं बताऊंगा, ये आपने सर ढूंढना है T1 कौन सा ज्यादा रहेगा, T2 कौन सा ज्यादा रहेगा। इज दिस क्लियर सर? यहां तक की क्लियर है? किसी को कुछ प्रॉब्लम है? Otherwise, is it clear whatever we have discussed up till now? Because then only the machine design part will start. Okay, so now the shaft design can be done by two approaches. So which one is good now that you have to decide? You have studied this. The first approach is approach 1. So you know that the get the design torque TD, which is equals to 1.25 times torque to be transmitted. Torque to be transmitted means either of this one or this two. Okay, so now let us say that Fs is the permissible shear stress. Permissible shear stress for shaft material. Okay, so where from you get this? The step is select shaft material from data book and get the value. सर आपने बीडी शिवलकर का अगर आप डेटा बुक यूज करते हो तो वहां से लीजिए, या फिर आप पीएसजी वाला डेटा हैंडबुक सॉरी डिजाइन डेटा बुक यूज करते हो तो वो लीजिए, डेटा फ्रॉम डिजाइन डेटा बुक। ठीक है, वहां से लेंगे. फॉर एग्जाम्पल यू कैन सिलेक्ट स्टील 20 mn क्रोमियम 5, जिसका ये यील्ड स्ट्रेंथ है, yield strength is 650 megapascal. So Fs comes out to be 0.18 time SUT ultimate stress. So that comes out to be 117 megapascal. आप ये ले सकते हैं. I'm just giving you the example. Now the moment you select this, then use the formula. And third is use formula design torque TD by IP is equals to Fs divided by Y, where Y is the distance from neutral axis to outermost fiber of the shaft. So Y is the distance of neutral axis from the outermost fiber of shaft, that is equals to D by 2. Okay, and IP is your polar moment of inertia, polar moment of inertia. This is equals to pi by 32 d raised to power 4. तो सर आपको ऑलमोस्ट सभी वैल्यूज मिल गई है. सो फ्रॉम हियर गेट diameter of shaft. Okay, let us say that the diameter of shaft you get is, let us say that diameter of shaft from first approach is your D1 from this approach. Okay, now you can, have you understood this? सर ये समझा क्या आपको? तो आगे बढ़ते हैं सर. ठीक है, नाउ ये मशीन डिजाइन का है पार्ट, थोड़ा सा इसमें आप अपना भी माइंड लगाइए. आपने जो शाफ्ट डिजाइन सीखा हुआ है. नाउ द अप्रोच 2. Approach 2, what you have to use ASME code for shaft design. So what you have to do, so it says that the design or the maximum torque that has to be given by, so it has to be given by 16, okay, into root of KB into M times B whole square plus KT into MT whole square divided by pi d cube. So Tmax is the maximum permissible shear stress, or you can say this has to MB maximum bending. एक minute. It's saying that this is the, sorry, this has to be Tmax. मैंने गलत लिखा. So Tmax, he is saying that maximum permissible shear stress, MB, is maximum bending moment, MT is the maximum torque. Okay, this is your equal to T design. Okay, and KT and KB and KT are fatigue. KT is the shock factor, so fatigue and shock factor. So here, please note that assuming no significant bending moment, so make that MB is almost equal to 0. So in that case, your Tmax comes out to be Tmax is equal to 16 into KT into MT divided by pi d cube. Take KT is equals to 1.25. This is suddenly applied load. Suddenly applied load with minor shocks. ये वैल्यू आप KT की ले सकते हो. From here, get the value of diameter of shaft as D2. Okay, so now from here, from approach 1 and approach 2, select the maximum diameter and match with standard shaft size. Okay, so this is how you can design the diameter of the input diameter of the gearbox shaft. Okay, तो सर यहाँ पे एक चीज आपने याद रखना है कि यहाँ पे एक चीज आपने याद रखना है, एक वो कौन सी चीज है, this is basically based on whatever things which are available, but we are taking the values from the actual specification. So this is the only way for designing the shaft. So if possible for you people to get the diameter of the input shaft of the gearbox which is used in your specific model, you can search on the net and please try to match the size of this diameter, that which one is, that means you won't get the exact match because we do not know that what kind of factor of safety they have used, but usually here in this case we have modified it. The maximum torque we have, if you see here, the modified by 25%, so we are using factor of safety of 1.25. so definitely our shaft size which we get from the calculation will be more than whatever used in the automobile. Usually in the automobile, the factor of safety is of the order of 1.12 is taken. It is only 12% margin which is provided, because if you don't do that, then if you are using higher factor of safety, that means you are unnecessarily making the things heavy. That is first thing. Second thing, the cost is a very sensitive issue in the automotive industry. That means cost will increase. So that is basically the major issue, as far as the automotive industries are concerned. So therefore, usually you will find that usually the factor of safety used in industry is almost 1.12, that is 12% more value for designing. That means if you have got the 100 load, then they will consider it as 112 as a load and they design for that. Then also the shafts, they are tested for fatigue. The shafts are also tested for fatigue failure because of the, and usually 10 raised to power 5 cycles are taken to be a safe limit. That means the shaft which can sustain for 10 raised to power 5 cycles, then that is taken as the safety, you can say, limit. That means then this can last for the long. And as you know, the fatigue curve, so that is basically, it is used in the staircase method of fatigue testing is used. That means if you increase the load factor, let us say you go on increasing the load by 10%, and wherever the shaft fails, then you come back to the lower cycle and again test it. And if it survives, then again go to again increase the loading. If it is surviving there, then you take the next step. Otherwise, you come back to the previous step. So this is how the step by step the shaft load is increased and it is tested for the fatigue loading. There is a huge setup of the fatigue testing there in the area. Okay, so this practical is very short. So I hope that you will able to do this practical. After this, we have got the practical related to brakes. So for that, we will not require that much data, but for the AC system practical, we will require the data. So try to gather the data for your own kind of vehicle which is there, and what is the specification of AC system and other things. The other practical which you can do it with this also, whenever you visit to the service station, then please try to take the photograph of the front end auxiliary drives कि वो कैसे उन्होंने fit किए हैं, what is the location and what is the ratio at which the compressor is driven, at what speed the compressor, water pump pulley, alternator pulley, they are driven. So please visit the workshop at least once for your kind of vehicle कि जहाँ repair होता है या कहीं garage में जाके तो भी देखिएगा, ठीक है? So this is what is for today. So do you have any question? And one more thing, please keep on writing all these things because I may ask you to submit the practical after the mid-sem so that you will be free. So sir, ये लिखना आप चालू करिए. So if you have any questions, sir, please ask. We will be required to take higher FOS as we are not taking bending moment. Sir, higher FOS, please don't take it because already the industry is taking as 1.12, we are taking at 1.25. So 12% we have already increased. So don't take higher, you can say, factor of safety. Okay, it will be compensated by the that 12%. ठीक है. और वैसे भी क्या करेंगे दुर्गे जी कि हम लोग दोनों इससे एक डायमीटर निकालेंगे. नेचुरली जो मैक्सिमम पावर वाला है उससे आपको टॉर्क कम मिलेगा और जो मैक्सिमम टॉर्क पॉइंट है उसके लिए ही हमको डिजाइन करना पड़ेगा. दैट इज फर्स्ट थिंग. Second thing, whatever values we are getting, that we are getting the non-standard value of the shaft. So we are going to round it off to the next standard which is available. So this by this you will search also what are the standard shaft diameters available. See, if you get the shaft size of, let us say, 21.34 and the standard shaft size is 24, then you have to shift from 21.34 to 24 directly, because usually in industry that particular thing is done. That is one aspect. Second aspect is you can change the material and you can see that how the shaft size they vary. And if you are you can say much interested in that, then you can do you change the material and you find out the shaft sizes, and then from that you can assume the length of the shaft, get its weight, and find out the rate for that particular material. So which shaft is cheap, that you can also do it. Okay. So likewise, because see why I am saying so, because we did one value engineering project in the company. In our company, there was a debate going on regarding the crankshaft and connecting rod fatigue testing, and I was in charge of that crankshaft and connecting rod fatigue testing. So I used to go to Automotive Research Association of India, because at that time they were having the setup, and Mahindra was also having a setup, but it was at you can say at Kandivali. Okay, so what we used to do, we used to take the connecting rod and crankshaft and used to fit into the fatigue testing machine, and then used to test that. So somehow we succeeded in successfully completing the fatigue testing of the connecting rod and crankshaft. But when we came back, then whatever material we selected for the I don't disclose the name of that particular engine, for the new engine, then that material was cheaper. Then ultimately our boss told us that why can't we do this exercise for the all other engines, so that we should able to have the crankshaft of the material of which we got for the new engine, because that was cheaper material. So somehow we could able to do the fatigue testing of the entire platform, and let me tell you that that material which we selected for the new engine, it was costing only 9 rupees kgs, whereas in old engines the material was costing almost 10 rupees per kg. So now you imagine that 4 crankshaft, 4 connecting rod with same weight, reduced cost of 1 rupee. That means we were saving on one engine, we had a saving of 4 rupees. So almost with the company taxation and everything, it comes out to be 10 to 12 rupees. Okay. So 10 to 12 rupees saving on each engine. You imagine the number of engines manufactured per day, number of engines manufactured in 1 week, then 1 month, then year, and years together for 10 years. Okay, so that is those kinds of the projects, they are called as the value engineering projects, and we estimated that we did it for almost 3 engines, and we could able to save almost more than 1.5 crores. So in that year we could able to get the excellent ratings for saving more than 1.5 crores. That means हमारे जितना सैलरी नहीं था यार, उससे ज्यादा तो हम लोगों ने कंपनी का फायदा करके दिया. So this is basically the power of engineering. So this is what I wanted to share, and this exercise I did it, means it's not that I'm just telling you anything which I have not done, but this is the thing which I did in the company. So likewise, if you are good in technical calculations, so better to go ahead with that. Okay, so over from my side, if you have any query, any doubt, please ask. Otherwise, you can leave the meeting. But please make sure that all of you please do complete the practical. I am repeatedly telling you कि ये लिख लो सर practical. मैं एक भी practical का class miss नहीं करना चाहता, because I wanted to make free as early as possible. Okay. So sir, by February end we will be getting the actual setup of the Scorpio chassis in our lab. So once I receive that particular setup, I will show you the actual parts, the cut section of engine, gearbox, transmission and everything. So you will have a better feeling of what is basically the how does it look like and how the power transmission takes place. Okay, so hopefully it should come by 28th of February, because I gave ultimatum to the supplier that if you are not supplying, then we will cancel the order. ठीक है, so this is from my side. और अच्छी बात ये है सर कि should we write experiment 5 handwritten or in MS Word? Sir, you should write it in handwritten kind of thing. And if you are doing, see, I suggest you at least you do it for 2 materials. 2 material के लिए तो करो ही करो सर. ठीक है, तो हैंड रिटन करो सर, वो थोड़ा सा काम किया हुआ तो भी दिखेगा. ठीक है. एनी अदर क्वेश्चन सौरभ? तो सर आपके लिए एक अच्छी खबर ये भी है कि सर इलेक्ट्रिक व्हीकल का लैब को एक्चुअली पडोले सर हैज गिवन अस द परमिशन. तो बाय द टाइम आप फाइनल ईयर में जाओगे तो होपफुली इलेक्ट्रिक व्हीकल का भी लैब रहेगा. सो यू विल एबल टू सी दैट. अभी नया लैब का कंस्ट्रक्शन चालू है कैंटीन के अपोजिट. अगर वो हो गया तो अपने को वो भी लैब मिल जाएगा सर. अभी ठीक है, अभी सिचुएशन ऐसा है कि आप तो कैंपस में नहीं है, but when you come back to the campus you can able to see the electric vehicle lab as well. ठीक है. So over from my side, so now you may leave the meeting. Yeah, if you do not have any question.